Welcome back, fellow scientists. It's Justin again. I thought the studio could use some extra ambiance today, so I just finished hanging my favorite twinkle lights. And now, for the moment of truth. Let's try that again. Well, the lights just don't seem to want to turn on. What do you think the problem could be? Oh, it looks like there's a gap between these two lights, which means the circuit is open. Can you help me figure out something I could use to close it so the studio can be aglow? By the end of today's lesson, you'll be able to use the scientific method to test the conductivity of household items and draw conclusions from your results. Let's get into it. So, to get these lights glowing, we need to find a material that closes the circuit and allows the electricity to flow. To do that, we'll need a good conductor. A conductor is a material that allows electrical current to flow through it. Some materials are good conductors, letting the current flow through easily. And some are poor conductors, allowing some current through with resistance. Other materials don't allow current to flow at all. We call those insulators. But which materials make good conductors and which don't? Let's run an experiment and find out. We never want to experiment on broken wires in our homes, so for safety, we're going to be building our own circuits to test on. For this experiment, you'll need materials for building a circuit, including 3 coated electrical wires, a D battery and a holder, a small light bulb and a holder, and a trusted adult to help you. This experiment can also be completed with other battery sizes depending on what you have available. You'll also need to collect some items from around your home. Find 5 to 10 small items to test in your circuit. Make sure they're made of a variety of different materials. For example, you could collect things like a paper clip, a rubber eraser, a sticky note, even a potato. Before you start your experiment, make sure to test your circuit to ensure that all of the pieces are functioning properly. Set up your battery and light bulb in their holders and use 2 wires to connect them. If the light bulb doesn't glow brightly, check your connections or swap out your bulb or battery. Once all systems are a go, it's time to experiment. Follow the steps in the procedure to set up the circuit for testing your items. If an item is a good conductor, what do you expect to observe? How about an item that's not a conductor? I think you've got the bright idea. As you test your items, record if they are good, poor, or not conductors at all in your data table. Then use your results to determine what materials make the best conductors. And that's it. I can't wait to see what you learn about conductors so we can turn these lights on. I just know it'll be the coolest studio in town. Yeah. And remember, scientists, curiosity is the architect of discovery. See you next time. Hey, hey.